So what we're going to have then is, what if we have the fraction 5/6 and we're subtracting from it the fraction 1/4? We want to subtract these guys, but we see right away that we do not have a common denominator. We have a 6 and we have a 4. Now, the next thing we look at is, hey, can we transform one of these fractions, for instance this one, to put a 6 on the bottom of it? Well, I can't multiply 4 times anything to give me 6, so I can't really do that. I also can't just transform this fraction to make it match this one because I can't multiply 6 by anything to give me 4. So the first thing you do is always try to do the simple thing. See if you can just change one of those fractions to give you the common denominator of the other one, right? But we can't do that in this case because we've chosen these denominators so that you can't just do it by changing one of those fractions. So then we start looking for what would be a good common denominator between these two fractions. We clearly need to transform these fractions, but what should we use as a common denominator? Now, it's a little bit of technique here. It's a little bit of technique here, but what you do is you look at 6 and 4, and you start going up and you start in your head, and you start trying to figure out what number can I choose that will allow me to divide 6 into it and also 4 into it. Because what I need to do is say 4 times something is going to give me that number, and 6, the other fraction, times something will give me the same number. I need to find a common number that will be divisible by 6 and 4. So we start going mentally up. Well, 6 isn't going to work, can't divide that by 4. 8's not going to work, can't divide that by 6. Okay, then you go to 10. You just kind of mentally go up in your head, what do you think would be divisible by 6 and 4? Eventually I'm going to get to 12. 12 can be divided by 6, and 12 can also be divided by 4. So I single out that and I say I'm going to use 12 as my common denominator. Now in order to do that, I need to multiply this fraction by 3 on the top and the bottom, because that'll give me 12. And down here I will have 3/12 for this fraction. 1 times 3 is 3, 4 times 3 is 12. All right? And then I go and do the same thing up here. I say 5/6. Now I obviously want to get a common denominator of 12, so I need to multiply this times 2 and this times 2, because 6 times 2 is 12. So then what I will have on the top will be 10, and on the bottom will be 12. So now you see what I've done. I have changed this fraction into 3/12, and I've changed this fraction into 10/12. I haven't changed what this fraction represents over here or what this one represents over here. These are equivalent, right? But they look different and they have a common denominator. So now I'm able to do the subtraction. I just put a minus sign here, draw a line, and say I'm going to subtract. And then I know now I have a common denominator, so 12 just stays on the bottom. And on the top, 10 minus 3 is going to give me 7. So the answer is 7/12. I always try to see if I can simplify this any further. I can't divide top and bottom by anything to simplify this anymore, so 7/12 is the answer. I want to make sure you know that in this case we happen to pick 12 as our common denominator. And that was the number we were trying to multiply these denominators with to get us 12 as a common denominator. But there are plenty of other numbers you could choose as a common denominator. You're not limited to one of them. You could pick whatever you want for a common denominator. For instance, the number 24, all right? 6 times 4 will give me 24. 4 times 6 will give me 24. So I could have transformed those fractions so that I had a 24 on the bottom and a 24 on the bottom up there. And if I had done that, then I would subtract it. I would be getting a different answer here, but then I would be able to simplify it. And when I simplified, if I were to do it that way and simplify it that way, I would still get 7/12 as my final answer. No matter what you pick as a common denominator, if you do the math correctly and you get the answer and you fully simplify it, you're always going to get the same thing. And I feel so strongly to show you that this is the case that I actually want to take just a minute to show you that this is the case up here. So let me draw kind of a double line here to kind of separate it here. I want to show you, what if I wanted to pick 24 as a common denominator? Well, I have 5/6, right? And I want to transform it. I'm going to say, well, I'm going to multiply this by 4 and this times 4 because I know that this will be 20 and on the bottom this will be 24. All right? 6 times 4 is 24. This fraction, 1/4, I'm going to transform that one. How would I do that? I'm going to transform it by multiplying top and bottom by 6. Right? And when I do that, I will get 6 over here, and I will get 4 times 6 is 24 on the bottom. So you see, because I chose to use 24 as a common denominator, these fractions here, they look quite a bit different than what I did before. All right? But I'm going to show you that you're going to get the same answer in both cases. Because if I subtract it here, I'll still get a 24 on the bottom. But on the top, I'll have 20 minus 6. 20 minus 6 is 14. So you see the answer I got here was 7/12. The answer I'm getting here is 14/24, but I can simplify this fraction because I know that it's divisible by 2. Divide the top by 2, divide the bottom by 2. What do you think I'm going to get? 14 divided by 2 is 7. 24 divided by 2 is 12. I get exactly the same answer that I got before. It doesn't really matter what common denominator you pick. As long as you do the math correctly and subtract it and simplify it, you're going to get the right answer. Right? So that's kind of my little aside for you. I want to make sure you understand that as we do fractions. You know, a lot of people think there's only one way to do it. There's lots of ways to solve fractions problems as long as you're doing everything legally. So now we have the fraction 2/3, and we're subtracting 2/7. Right? So we want to solve that problem. We have a 3 and a 7. I'm trying to look for a common denominator between them, and I'm having a hard time coming up with something. So I always go to my fallback. 7 times 3 is 21. So I know that when I multiply the denominators, I can always use that as a common denominator. And I'll show you what I mean by that in a minute. If I have 2/3, if I'm trying to shoot for 21 as a common denominator, I'll multiply this by 7 and that by 7. 2 times 7 will be 14. This will be 21. I'm shooting for 21 as a common denominator. The 2/7 I can transform by multiplying by 3/3 because I'm trying to reach, again, 21. Then I'll have 6 on the top, 21 on the bottom. And I can subtract these. This is a valid common denominator between them. Sure, there are other common denominators out there I could pick, but if you get stuck and you can't find something that's small, then just take the denominator times the other denominator, and then whatever you get, in this case 21, shoot for that as your common denominator. That'll work every time. All right, so in the answer, 21 is common, so I keep that in my denominator. 14 minus 6 is going to be 8. So I'm going to put it 8 over there. And then I'm going to look at this and say, can I simplify this any further? And I really can't, because 8/21, I cannot divide top and bottom by anything. Can't divide by 4, can't divide by 3 on the top and the bottom. So 8/21 is the final answer there. All right. Next, let's work the problem. 3/4 minus 2/9. Again, I look at 4 and 9, and I start looking and saying, hey, what could I choose as a common denominator between 4 and 9? I start going up and up there. There are probably lots of choices there, but I'm going to zero in on 36 because I know that 9 times 4 is 36. All right, and so what I'm going to do then is I'm going to say 2/9, and I'm going to transform this into 36. Multiply by 4, multiply by 4. 2 times 4 will give me 8. 9 times 4 will give me 36. And we'll do exactly the same thing on the top. I'll have my 3/4, and I'll transform that by multiplying by 9 and by 9. 9 times 3 is 27, and the bottom is still 36. So now I have a common denominator, and I can subtract these two fractions. Now, of course, 36 is the denominator, so I can just keep them here on the bottom. And I subtract the top. 27 minus 8 should give me 19. So I have 19/36. I can't really simplify that anymore. I can't divide something into 19, something into 36, the same common number, and simplify this fraction any more than it already is. So 19/36. All right. Just a couple more. We want to build our skills. All right. What if we have 7/10 and we're subtracting 1/4. All right, so I have 10 and 4, and you know, there's lots of choices I can choose. I know that I can choose 40, right, because 10 times 4 is 40, so of course I can choose 40 as a common denominator. That would be perfectly fine. But I also think that 20 would work as a common denominator because 10 times 2 is 20, and 4 times 5 is also 20. So I'm going to always try to pick the smaller denominator if I can, because smaller numbers are generally always going to be easier to work with. So let's pick 20 as a common denominator. We'll have 7/10, and we'll transform that by multiplying this guy by 2 and this guy by 2, and so I'll have 14/20 right here. And then here we'll transform this one by saying 1/4, and we'll multiply this guy by 4 times 5 is 20, so I'll multiply top and bottom by 5. So over here I'll have 5/20, and I'm subtracting these two fractions from one another. Now I already have a common denominator here, which is 20. So now my common denominator is 20, so I'll just keep him along for the ride. And now I subtract 14 minus 5, which will give me 9. 9/20. That is the final answer. So I don't have to simplify this anymore because I cannot divide top and bottom by something to simplify this fraction. Now here I chose 20 to be my common denominator because I happen to think of that. I'm going through mentally looking for numbers that 10 can divide into and that 4 can divide into, because I need to ultimately multiply these by something to give me that number, and I landed on 20. But if I just didn't think of 20, right, then I can always go to my fallback. 10 times 4 is 40. 40 will always work as a common denominator. When you multiply those denominators, whatever you get, 40, if we would have done it that way, we would get different fraction here, but it would be over 40. We'd have a different fraction here over 40. When we subtract them, we would have gotten something over 40. But the difference is we would have been able to simplify that fraction, but we would have still gotten 9/20 at the end of the day. So keep that in mind. That's why I showed you in the previous problem that that was the case. Now let's do our last one. What if we get 2/3 minus 2/8? 2/3 minus 2/8. And I'm looking for a common denominator, and the one that just jumps out at me when I see 8 and 3 is 24. So I'm going to go ahead and transform this into 24 because I know that 8 times 3 is 24. So 2/8, I'm going to multiply this one by 3 and this one by 3 because I'm trying to get to 24. And I'll get 6 over 24 when I do that. And this one will be 2/3. I'll multiply this one by 8 on the top and 8 on the bottom. 2 times 8 is 16, 8 times 3 is 24, and I'm going to subtract them like that. So now I have a denominator of 24. That will remain as 24. 16 minus 6 is a nice 10. So I get 10 over 24. Now I could circle that, but then I need to always check, can I simplify this? And I can divide this top by 2 and the bottom by 2. They're both even numbers. And what I will get, 10 divided by 2 is 5. 24 divided by 2 is 12. And I cannot simplify this anymore. 5/12 is fully simplified. I can't divide top and bottom by anything to make that any simpler.